Hello everyone. Today let us discuss about the NS2. As I will be giving only introductory presentation on this, so I will call the topic as a beginner approach towards NS2. So first let us see about what is network simulation. Network simulation, it is nothing else, is purely a programming model that actually behaves as a original network. How do we achieve this in a sense? It is by providing a mechanism that can inbuilt with the different entities like the number of nodes and connecting devices and the transmission packets. Those can be controlled through the mathematical formulas in the network simulator. The simulation results, if the simulation results are trustable, that is accurate, then only we can validate the simulator or simulation for any designed network. We have plenty of simulators, out of which we have listed a few here, starting with the NS2, NS3, OpNet, NetSim, Real, QualNet, JSIM, and etc. Once we know about the network simulator, then let us see about the network emulator. What is the major difference we find between the network simulator and network emulator? Network emulator, which actually allows you to introduce the real kind of devices into your simulator or your model or methodology, which can give you the real packet flow, which can reduce the majority of loss or the errors which do occurs at the time of simulation. Then let's move on to the building the network simulator, and here we will be concentrating purely with respect to NS2, network simulator version 2. How do we build the environment related to the network simulator? Here we do make use of the two programming languages, which are C++ and OTCL. However, you all well known related to the C++. What about the OTCL? OTCL, which is an integrated of C++, something like object oriented version of the tool command language. TCL stands for tool command language. And any network simulator package will be inbuilt with the n number of protocol objects that we are going to see further. So here, whenever you say it as OTCL, so whenever you say it as a OTCL, which is it is a combination of TCL and object oriented OO. Then why do we use the OTCL in the sense that is to configure the NS2 system? Let's move on. What is the necessity or applications of C++ or OTCL in our NS2? Whenever you do make use of C++, there are few advantages of it in our NS2, that is to increase the efficiency of our simulation in the NS2. It also provides a complete details of the protocols and the operation of them, whichever we are using in our simulation, and mainly it reduces the processing time. You say it as packet and event processing time. The time will be reduced whenever you make use of C++. What about OTCL? OTCL, object oriented TCL, that is to describe the topologies. Whenever you think about the n number of nodes to be present or to be placed in a network, how to place them in a network, what is the structure to be followed to place them in a network, that is a means of what are the different topologies you need to follow and what are the protocols you need to apply there. And also very importantly, developing such kind of networks topology or simulated topology is so fast when you make use of OTCL. And majorly it is very easy and it is free. You don't have to pay for it. It is free to use. Then here is this architecture depiction of the NS2. As such, this is where you write the OTCL script that can simulate your network. As soon as you are done with your OTCL script, you run that. As soon as you run, what happens in the sense, there is a TCL interpreter. That TCL interpreter interprets each and every instruction in your program so that it produces the simulation results. Such simulation results you can analyze. The produced simulation results. If you want to see that graphically with the best user interface, then you can make use of network animator for the user visibility. Such kind of simulation results are considered as a trace files. So here is an example. Here if you observe, the TCL script which is generated by the user or the programmer, that is when you execute it through what? By using the NS2 executable command. What is the command? It is just NS. When you execute it, what happens in the sense, which by making use of your C++ and the OTCL, which is inbuilt with a set of objects which produces the simulation trace file, the TR file. Remember, the file extension for this TCL simulation script, it is .tcl. It will be .tcl, and what is the command to execute? It is just NS followed by the file name .tcl. So this is the source file name with the .tcl, and this is the command to execute NS followed by the source file name .tcl. That produces the source file name with the .tr, which is the trace file. From that, it is left to the user to produce whether you want to analyze this simulation results. You want to analyze the simulation results through the visualized animated depiction, or the user want to analyze the results through the graph after you plot. So for visualize animation, we will be using the NAM, network animator. For graph plotting, we will be using the X graph. If you make use of the network animator, this is how it looks. So where we'll be having a set of nodes which are being connected through the connecting devices, and there will be links to connect, and this is what the flow of data which it will give you the actual packet flow. If at all if you want to analyze based on the graph, this is how the X graph, by using the X graph, this is how you can analyze the graphical representation over the X graph. So, and these will give you the actual variation in the respective parameters. You may consider the parameters with respect to data flow, bandwidth variation, power variation, etc, etc. So remember, this is the complete architecture of NS, where you will be having your own source script which is written by making use of your TCL scripting instructions, which we are going to see further. The extension for this file name is the .tcl, and how to run it? It is just by making use of NS command. What happens? What it produces? It is the trace file. From that trace file, either you analyze the results through the network animator, or by making use of the X graph by producing the graphical representation. Now let us move on to the basics of TCL programming, and here we will be presenting with respect to only NS2. Whenever you consider with respect to basics of TCL programming, or before you begin with the generating the complete programming, you should know about the how to deal with the 5 major factors or 5 different aspects here. The first one is how to initialize and terminate the simulator. Next, how to place the nodes in it and connect them by using a links, and how to initialize the buffer space for data transmission, and how to place them in a specific topology. As a third factor, you also should deal with the agents, the client agents and the server agents, are the end agents, the source end and the destination end. How to create them, how to create those agents, what are the ways of creating them that we should deal. Once after a complete simulator is ready, then how to visualize them in the network animator, and finally let us discuss about the result details, which is called as trace file content. Starting with the initialization, here is a simple instruction, or you say that a script, which is set space ns new simulator. In this, set is a command, ns is a variable. Ns is a variable. What it happens in the sense, you are creating a pointer variable. This ns is a pointer variable that is to hold the simulator where it is initialized by the keyword new. So set is a command, you can say it as new is also command, ns is a pointer variable, simulator is the this is the class which is created or which is inbuilt or which is available in the NS2. This is the class file. So by using the set ns new simulator, remember set and the new, you can call it as a commands, or you can say the reserved keywords. ns is the pointer variable and this simulator is the class which is available in the NS2. So you are initializing this simulator by using this new, and that is pointed by using ns pointer, and you are making this ns to point to this class by using this set command. So that is how you initialize the network simulator, set ns new simulator. Once you deal with the initialization of a network simulator, then you should also know how to deal with the output files. Here you consider about the two different output files here. One is the trace file and another is the nam file. Coming to the trace file, the extension for the trace file is the tr, whereas the extension for the nam file is the .nam. So .tr and the .nam are the extensions for the output files we are going to consider here. So you can create, these are the two output files which are created, the .tr and the .nam, but which are, as we supposed to put some, or as we supposed to store the final results into these two files, which is trace file and the nam file, we are going to open that file with the access specifier as the w, which is the write mode, as we want to push the result into these folders or these files, trace file and the nam file. So we are opening those files in the write access mode, wherein these are the comments, which is hash followed by a content, which is the single line comments. What about here, how it works in the sense? Remember the output.out.tr and out.nam, even though they are considered to be output files, but these cannot be called by the, or your NS2 cannot call these directly with these names. It cannot be called as out.tr and out.nam for the NS2. It is for the users, it is out.tr and out.nam. But how does your NS2 can point these out.tr and out.nam in the sense by using this pointer variable, which is nam file, trace file 1 and nam file 1. Now coming back, here is a command which is something like set trace file 1 open out.tr w. What happens? As usual, set is a command. Trace file 1 is a pointer variable that is to point to where? That is to point to the trace file. What is the name of the trace file? It is out.tr. How do you open that? It is by using the open command. Open command. And in what access mode you are opening? You are opening with the write mode. So it is set is the command. You are setting the trace file 1 pointer to the out trace file. What is the trace file? It is the out.tr, and that is opened in the write mode by using the open command. So in the same way, set is a command which is setting the nam file 1 as a pointer to the nam file. What is the nam file? It is the output.nam that you open with the write access mode by using the open command. That is the complete flow. But what about this trace all in the sense? Basically, trace all is the actual executable command which traces all the events in the flow or events in the format. So this tracer which traces all the events in the trace file, whereas here nam file which produces the complete depiction of your nam file, which is out.nam. Here out and this out.tr and the out.nam, .tr and the .nam are the extensions, and this out is the file name. If you have used some source file name as source.tcl, then this would be source.tr and source.nam. So this is the file names and these are the extensions. So likewise we will be using the two types of output files here. After we know about the initialization, let us deal about the termination. So coming to the termination, you can terminate your complete simulation by using the separate procedure that you call as a finish procedure. How do you define that finish procedure? It is by using the keyword PROC, and this is the finish procedure, and here we are using the global keyword, that is to say that the following variables, these are the pointer variables ns and trace file 1 and nam file 1, are not restricted to this procedure itself. It can be used anywhere to make these variables pointers as global. So we will be using the global here. So then what does this flush trace will do in the sense? Again, as usual, this flush trace is a simulator method. What it does in the sense, it dumps all the traces. Whatever it is carried out will to the respective output files. Which are the respective output files? It is out.tr and the out.nam. Then close command, as the name itself specifies, it closes the trace files. Once the dumping is done, then it closes the trace files. Then we have exec, the executable command, so which actually initializes the nam file for starting the visualization of the executable file for the user appearance. That is will be done by the exec or executable file. And finally we have exit, which actually closes the complete application, and 0 which indicates the clean exit. So till now we saw about the termination. Now let us see about the start and end instructions or objects. We have the command or the script, which is by using this run command you can start the simulation, and by using this, when you want to end it, you need to call the finish. So it means to say that you started after 125 seconds. After 125 seconds, you are calling the finish procedure. You are calling this finish procedure. Where is the finish procedure? This is here. So you are calling the finish procedure after 125 seconds to come to end the simulation. So this is where you are starting the simulation. This is where you are ending the simulation. Then let's move on to the next factor. So till now we saw how to create the network simulator and when to start and when to stop. But now let us see how to place the number of nodes, how to place the n number of nodes into that simulator, and how to connect them, and how to create the buffer or the queue to hold the packets to be transmitted from one node to the other node. So coming to the creation of a node, this is what the simple command where we'll be using to create the node as set, as usual a command followed by n1, which is the name of this is the pointer variable to the particular node, and the new again as usual a command, and the node is the object. Node is the object, or you can say that class which is available in the NS2. So node is the class which is available in the NS2. New is the command, or you say that keyword, and the set is again a command or keyword. So here what happens? You set the n1 as a pointer variable to the node which is initialized by the new command. And what is the node? This node is the class which is available in the NS2. Now this n1 is a variable pointer which already is set, so it can be any number. So based on the number of nodes you want to create, you can have so many number of statements. So if at all if you want to have 2 nodes, so then you need to have set n1, set n2, new node, new node. If at all if you want to have 10, so you explicitly you should declare or define as set n1, n2, n3, n4 till n10. So like this, n number of nodes need to be declared explicitly in this way. So what about once after the nodes are created, then how to connect them? For the point like how to connect them in the sense, for connecting them you can make use of either duplex link or it can be simplex link. What happens if you make use of simplex link? However, the name itself specifies, which is purely a one-way transmission. So one-way transmission. So whenever you want to have a two-way transmission, when and all if you want to have a two-way transmission, then you cannot make use of simplex, you must make use of the duplex link. So that is where here it is NS in the network simulator, you are creating the duplex link. You are creating the duplex link between where? Between N1 to the N2. Between N1 to the N2. With what bandwidth or frequency? It is the 10 MB. If at all if you want to consider as a bandwidth, it is 10 MB. If you consider with respect to the frequency, it is 10 Mbps. So that is what? 10 megabits per second. Then moving to the 10 ms. What does this in the sense? It is the delay which can occur. The delay which can occur between the transmission. That is what? A delay in the transmission, 10 milliseconds. Then finally drop tail. So this last factor which you are supposed to know, it is all deals about the working with the congestion controlling in the queue which will be initialized over the link. So you are initializing the queue or the link between the N1 to the N2, and what type of link? It is the duplex link. From where? From N1 to the N2 with a capacity of 10 Mbps and which has the 10 milliseconds of delay. And in that queue, how to overcome or how to handle the congestion controlling in the buffer. So in order to handle that queue handling or the buffer handling, we have the multiple mechanisms, so among which we are using the drop tail. What happens in the drop tail in the sense, as the name itself specifies, drop tail, when the queue is full, or the buffer is full, which will be dropped in the sense, which the packet which arrived at the last. That is what, if the buffer capacity is exceeded, then the last packet which is arrived will be dropped. That is what it is, drop tail. Drop the packet at the tail side. So that is what drop tail. Again remember, the D should be caps and T should be caps. Drop tail option. And there are the other few other options as red, as however the well-known red mechanism, randomly discard, RFQ, again fair queuing. Again we have DRR, deficit round robin mechanism, SFQ, stochastic fair queuing. So like that we have other multiple options as well. So whereas in this statement we are using the drop tail, which actually drops the last packet which is arrived at the tail part, which is tail end. So likewise you created the nodes and you set up the link between them, and you also initialize the queue handling mechanism, which is by using the drop tail here. Then we should also set the capacity of the buffer, and that buffer capacity can be set by using this queue limit. Remember, it is queue-limit. Queue limit between where to where? Between the N1 to the N2, because so we created the link between N1 to the N2. We created the link between N1 to the N2, and that link we consider as a duplex link. We also set the queue handling mechanism, but here we are setting the what is the maximum limit of that queue. Because just in the previous slide here we said that once after the queue size is exceeded, then the last packets are dropped. But actually what is the size of the queue or size of the buffer? Here we said that once the buffer size is exceeded, then the last packets will be dropped. But what is the size of that buffer, which is initialized in this with this instruction as, or with this command as, queue limit, and here we are setting the value as 20. So here we are setting the packets, maximum number of packets that queue can hold. It is 20 packets only. If the queue is full, that's what queue is enriched with the 20 packets, even there are few more incoming packets, such packets will be discarded or dropped based on this drop tail. So that's all belongs to the how to create the nodes, how to connect them by using the links, and how to deal with the queue. So this is the queue handling mechanism, and this is, and here is a command to set the maximum limit or the queue size. So here is the 20 packets. So then let's move on to the agents, which is the very important here. And here we are going to deal with the agents with respect to the two factors, as whether once after you create with the links between the n number of nodes, then you should also set whether those links has to work with respect to the service. What kind of service? When I say service, it is connection oriented service or it is a connection less service. So when I say it is a connection oriented service and connection less service, when I say it as a connection oriented service and connection less service, for connection oriented service as usual will be using the TCP protocol, whereas for connection less service will be using the UDP. So connection oriented TCP, connection less UDP. Now let us see with the TCP. So as usual, TCP which do requires the bidirectional link. Why do we need the bidirectional link? Where there is when there is a necessity of acknowledgement sending back from the receiver back to the source, or the destination back to the source. So from source to the destination, packets will be flowing. From destination back to the source, acknowledgements will be flowing. So there is a necessity of the bidirectional. So there is a necessity of the bidirectional links here in case of TCP. So it is not only the bidirectional link. You should also, however, we said as TCP is a connection oriented service, so there is a necessity of you to set up the connection before you can transfer the data. So as you set up the connection before you transfer the data, so it is a reliable congestion. So it is a reliable congestion protocol. How to deal with that? How to use this TCP here in the sense? Understand this again, as usual, we will be using the set command followed by the TCP. So here the TCP again is a variable pointer. This is a variable pointer. It is not the constant factor. It is a variable pointer. You can use any name here. So set is a command. TCP is the variable pointer to point to where? To point to the TCP agent. Again as usual. So set and the new are the commands. TCP is the variable pointer. What is this? This is the object. This is the object which is available in the NS. So you are setting a pointer variable. This is the TCP to the agent. Which agent? TCP agent. What does the TCP agent? Here it is the object which is available in NS, and that is initialized by the keyword new. Once after you made this TCP as a pointer to the TCP agent, then throughout your program, whenever you want to access the TCP agent, you can simply just make use of this variable pointer. So as such here. So what does this next instruction does here? It is attach agent. This is again a command or the keyword attach -agent. What happens in the sense, you are attaching the TCP agent. You are attaching because this TCP is a pointer to the TCP agent. So you are attaching that to the N1. N1 is the node which is created by using the already created N1. So how did we create N1? It is by using like this, by using set N1 new node. Like this we already created the N1 node, and that you are making it as a TCP agent here. How? You are attaching the TCP agent to the N1. What is this TCP? This is the variable pointer to the actual TCP agent. So what happens? N1 will become the TCP agent. Then you say it as a N1 will become TCP agent, but actually is it a source TCP agent or destination TCP agent? What I mean to say, is it a sending or is it receiving? In the sense, this N1 will act as a purely source TCP agent or a sending TCP agent. So because this is the TCP agent and here we are using is just a TCP, so it will act as a sending TCP agent or sending TCP node. What about the receiver or whatever the destination in the sense, that can be initialized by using the TCP sync agent. Whenever you talk about the TCP sync agent, again as usual, you set the sync, again sync here, sync is again a pointer variable. Again here sync is a pointer variable that is to point to the TCP agent, whereas here this again here initializing the TCP agent itself, but this will be acting as a sync agent, which is a collecting agent. That is means to say that receiver or the destination. And again as usual you attach that sync agent to the N2 by using the attach agent. So by this 4 lines what we did, we created the 2 TCP agents. One is by using the just a TCP agent, other one is a TCP sync agent. This TCP agent will be acting as a sender or the source, and TCP sync agent will be acting as a will be used at the receiver node or the destination node. As you attach this TCP to the N1, so N1 will be node 1 will be acting as the sender or the source, whereas TCP sync will be acting as the receiver or the destination. So that is what we did till here. Now we have the 2 nodes. One will be acting as sender TCP node and the other node will be acting as the destination TCP node. Now we need to connect those by using this connect keyword. That is what we do. By using this connect keyword, you connect TCP and sync. What does the TCP? It is the sender TCP agent, and the sync is the receiver TCP agent. That is what the sync agent. You need to connect them by using this connect keyword or connect command. You can connect them both. Because it is a TCP, there is a necessity of you to establish the connection before you can transfer. That is what will be done by using this connect. Then remember, in the actual networking there may be the n number of data transfer over the network. You can't restrict to be a one-to-one. So whenever you have a multiple data flows or multiple data communications, how to identify or how to differentiate one data flow to the other data flow, that is why you will be using this FID, which is the flow ID. This flow ID, which is to differentiate the one data flow to the other data flow in a n number of data flows which actually happens at the same time. So this FID, by using this FID you can differentiate that. So how do we do that? So you remember, under the TCP itself you may be having n number of data flows. Under the TCP you are differentiating by using this numbers. As if you say that TCP set FID underscore 1 2 3 like that, you can differentiate the n number of data flows over the same TCP. That is what this FID. And finally, so till now we created the 2 nodes, we connected them, we also differentiated or we also assigned the flow ID for that. But what is the maximum packet size you can transfer at the same time? So that is what this packet size all deals about. Because in the previous slides we said about the queue size. Queue size only deals about, or the queue limit will deal about the maximum number of packets in a queue. But what is the size of each packet, that you can set by using this packet size. Again remember, S caps, packet size, S caps. How do we set? Again as usual, you are setting this packet size with respect to the TCP only. With respect to the TCP you set the packet size, and here it is I just considered the example as 552. But if you don't set, what happens? Is it necessary to set this? Is it necessary to set this flow ID? Need not be always. If you don't set this flow ID compulsorily, then you can't identify your flow with respect to the n number of transmissions. So if you want to identify yourself, then you need to set this FID. Again as usual. So is there a restriction to set this packet size every time? Need not to be. If you don't set this packet size explicitly like this, then it will be using the default size as 1000. Instead of the variable number, it will be 1000. If you want to be your own value, if you want to vary the packet size and check the simulation results how it varies, then you can make use of this packet size to vary your packet size of the data transmission and check how the results will vary, so that you can do in this packet size. Then FTP. So however we say it as FTP, which is a well-known protocol, so which is used over the internet whenever you want to have a client server communication. Yes, it do provides the client server communication, and it also do make use of the services of the TCP. Whenever you say it as a do make use of client server communication, but it do make use of the 2 connections or 2 connectivities between the same client and the same server. and as it requires for the two connections. Why it needs the two connections? In the sense, one connection for the controlling or control transfer, and the other connection for the data transfer. As it requires the two connections, it requires the two different ports. 20 and 21 are the constant port numbers used by the FTP, wherein port number 20 is used for the actual data transfer, and port number 21 will be used for the control connections. Then how to initialize and how to use the FTP or the TCP. Coming to that, again as usual, you need to set, you will make use of set, and here FTP is again a pointer variable that is to point to the FTP agent. And remember, now the FTP is not the agent, it is only the application. So TCP and the TCP is the agent. So here you used as agent / TCP, wherein FTP is not the agent. FTP you are using over the TCP, so which is only for the specific application, and here we are using the simple client server application, which is one to transfer, other to receive, where the receiver has to send back the acknowledgement. So for that purpose, so FTP will be used as the application over the TCP. So you initialize the FTP application by using this as usual set and the new, and that is pointed by using this FTP pointer, and attach that FTP pointer with the TCP. So that's what will be done. FTP attach agent to the TCP. So remember, TCP is the agent, over that FTP is the application. So you will be attaching the FTP over the TCP for the respective client server application purpose. So that is all about the TCP and the FTP, which is we are going to use for the connection oriented service. Now let's move on to the connectionless service. However, you said as a connectionless service, you don't have to create a specific channel. So there is no requirement of a specific channel for your data transmission, and any node can keep transferring the messages in the form of a datagrams at any point of time. And as you do not have any specific channel, so you can say that this is a purely unreliable service. Why do you say it as unreliable service? Because the data may arrive at any order, and there may be the scenarios where the data may be lost. And data may be received for multiple times as well. Even though UDP will be used for connectionless services when there is a time constraint services, that's what you say, time sensitive applications. In such scenarios, you will be making use of the UDP service. Then how to initialize or how to set up the connection by using the UDP agent. So with respect to that, so again you see set UDP new agent. So here which agent we are dealing with? We are dealing with the UDP agent, not the TCP agent. So again as usual, this is the pointer variable again. This can be any name you can specify, a variable pointer wherein to hold the UDP agent. And what does the UDP agent? It is again an object which is available in the NS2. And you attach that UDP agent to the N1, wherein again as usual you made the N1 node, you made the UDP agent in the N1, but does it act as a source and the receiver, or the sender or receiver? In the sense, it's purely a sender node. How to create the receiver node? However, we create the sync node in case of TCP. You created the sync node with respect to the TCP. So how to create the receiver node here with respect to UDP? In the sense, it is not sync, it is the null agent. It is not the sync agent, it is the null agent. So you create the null agent, and that is pointed by using a pointer variable as null here, and that I am making to be a N2. So from these 4 instructions, it is very clear that you created the 2 agents, UDP agents, or one UDP agent at the node 1 and one more UDP null agent at the N2, and those to be connected together. So by using this connect, so you are connecting the UDP agent which is in the node 1 and null agent at the node 2 for the data transmission. Again as usual, under the UDP there may be n number of transmissions or n number of data flows. In order to categorize them or classify them or separate them or identify them individually, So you will be setting a specific identifier or the sequence number for each flow, data flow, that is by using this FID. So set FID underscore the flow number. So that is how you can create the UDP agent. So in the case of TCP agent, we will be creating the TCP agent, whereas in case of UDP agent, it is the agent slash UDP, wherein for that it will be acting as a sender node, wherein for the receiver, in case of TCP, we made use of the sync agent, wherein in case of UDP, you are supposed to make use of null agent here, which will be acting as the receiver to collect the data which is sent from the sender, and you will be connecting them by using the connect keyword. And in order to identify each flow one to the other, so we will be using the FID. We will be setting the flow ID or separate flow ID. That is all about creating the UDP agent. Then, as application specific, with respect to the TCP, we discussed about the FTP application with respect to the TCP, wherein here we are going to deal with the CBR. What is CBR? It is the constant bit rate, and basically this constant bit rate will be much used with respect to the telecommunications in order to deal with the quality of service, QoS of your telecommunications, and this makes sure that or ensures that the output data whatever it is generated, that should be a constant. So how to set up this CBR in the sense, again, however, we made use of FTP application. So here it is the CBR, again it is a application. Remember, it is not the agent. We are going to create this application, CBR application, for the purpose of UDP. So what we do? So set the CBR pointer variable for the application. What application? It is the CBR application. To analyze what? To analyze the traffic. So to analyze the traffic, we are going to create the CBR as an application that is pointed by using this CBR. So this you are going to attach again. You are attaching that with the UDP agent. UDP is the agent, CBR is the application. Again, as usual, you can set the packet size. It can be any size. It can be 500 or 1000 or 700. It can be any. So default, again as usual, default will be 1000. Again, set rate. It is which gives you the rate of transmission. Which gives you the rate of transmission. There should be a delay between the every packet to be transferred. That you will be setting here. And finally, here is the set random false. Remember, as we are dealing this CBR with respect to the UDP, and already I said in case of UDP there will be a means of the errors or the noise which can occur at the time of transmission. How to deal with such kind of noise? In the sense, for the purpose of dealing with the noise, there is this instruction or this statement will be used, which is CBR set random false. What happens in the sense, it is all means to say that to deal with the noise in the data transmission, whether you want to remove the noise or keep the noise. So it's something like you decide whether let it go with the actual data, let the noise go with the actual data, or you remove that and send only the actual data. So with respect to such kind of justification, you do make use of this set random. And what happens if you make use of this false? Means you are allowing the noise with your actual data. You are not trying to remove the noise. So that dealing with the noise over the transmission, we will be using this set random. So that is all about the creating the agents and the applications over it. Now let us move on to the scheduling the events. Scheduling the events which actually happens or which you can satisfy by using this at command. By using this at command, you can do this scheduling the events as such like this. So network simulator, you will be at the 0.1 second you are starting the CBR by using this start. At the same thing which is stopped at the 124.5 seconds. So at 124.5 seconds you are stopping that CBR which is started at the 0.1 second. Again as usual, at 1 second what you started, which is FTP service, that you stopped at the 124th second. So like that you can schedule at the based on the time series by using this at command or at keyword. That's all about the scheduling the events. Then let's move on to the next factor which is supposed to know with respect to the TCL in the NS2. It is NAM. NAM stands for Network Animator. This NAM, which is purely for visualization, how the network which is you simulated in the NS2, which is to be visualized to the user. So I say it as user interpretation. So for visualizing the network, we'll be using this network animator, and how best we can make it. So in that, let us deal about the few points here. As such, if you want to deal with the position of the nodes, the position of the nodes can be random or the constant. Whatever the duplex links we created between the number of nodes till now, if you just made use of them, then the position of the nodes can be random, or I can say it as a dynamic variable. It may be keep changing. The position of the nodes will not be constant. If you want to make the position of the nodes to be constant, then you fix up the particular origin. Based on the origin, you need to place the nodes based on these 6 factors. As such, you will, for any origin, orient, right up, right down, right up, right side, left, again left up, right. So like that you will be having the 6 factors as orient, right down, right up, right, left, left down, left up. Like that you can place the position of the nodes so to be a constant. So like that, position of the nodes in the network can be random or it can be a constant. It can be variable, which can be keep changing every time, or you can also make it static, which is by using this position parameters. You can make those. So if you observe, it was only duplex link earlier. Right now it is a duplex links OP, where it will be fixing the position, constant position node. Position of the nodes will be made constant, and those will be defined here. So like that, position of the nodes can be defined. Then moving to the color. So there is a possibility that you can also define the different colors in your animation. If you don't make use of this such kind of colors, then as usual it will be a black and white. So where it will be just a black and white. If not, you can make use of a standard RGB model to define the respective colors based on the requirement in the network animator. Then you can also provide the names for the nodes which are created in the topology or in the network. So that is what we call as a labeling, assigning the names which we call as a labeling. So that is by making use of this label keyword. By using this label keyword, however, for providing color, you will be using color 1, color 2, color 3, like that. It is, again remember, this color is a keyword and 1, 2, 3 are the numbers. And remember, there is a space between this color 1 and color 2. So it is color space 1, because color is a keyword, color is a constant, you call it as a command or the keyword, whereas 1, 2, 3 which are the variable number of colors. In the same way, for labeling for the n number of nodes, you can make use of the label keyword or label command. So label keyword will be using for assigning the names to the number of nodes. So that is what just an introduction about the network animator. Now let's move on to the very important trace file. So dealing with the trace file, as soon as you run your simulation in the network simulator NS, which do provide, not only give you the visual representation, it do also provide the trace file. So that trace file will be having the ASCII values. So before you see about the content of the trace file, you should know about what the four objects which are used. So those objects you can also say it as a tracing objects, which are NQ, DQ, receive and drop. So dealing with the NQ, as the name itself specifies, which only registers the arrival of the packets, which deals about the arrival of the packet which are pushed into the queue of the particular link. So as usual, we know that a link will be having the queue. So which link will be having the queue, whatever the packets which are arrived which are pushed into the input queue of the link, that will be those will be identified by using the NQ, which is the going inside to the queue. So wherein, so there will be a set of packets which may be dropped because of the when the size of the queue is limited, so the few packets may be dropped and those will be taken care. I mean, so those will be registered with respect to the drop T, which is drop data, drop packets, and DQ, so which will give you the DQ, whatever the packets which are available in the queue, so which will be holded by using this DQ, so which will be keep pushed into the which will be pushed from the queue, which are pointed by this DQ. And finally we have the receive. So when you are received into the queue, just receive T. So that is what 4 objects which we are going to see in the trace file. Now let's see the actual format of the trace file, and basically it will be having the totally 12 fields started from event, time, from which node, from to node, or sorry, to which node you are transferring, what is the type of the packet, what is the size of the packet, what are the different flags we are going to see, what is the flow ID, source address, destination address, and specifically sequence number, and finally packet number. So totally there will be a 12 fields here. Now let us see each field. First and foremost field, which is the event. So as the first field already it says that event, so the events, it can be any of the 4 objects whatever we saw till now, which is it can be NQ, DQ, receive, or it can be drop. How to identify them? It is by using the plus, minus, R or D. Plus is for NQ, minus is for DQ, R is for receive, and D for drop. So plus, as usual, whenever you get in, it will be incremented, so it is plus. When you drop it, it is minus. When it is received, R. When it is dropped, which is for D. So it is for plus for NQ, minus is for DQ, R for received, D for drop. So like that. So it is what? It is whenever it is received, it will be added. So plus. Whenever it is sent out, it will be minus DQ. Whenever received, you just say it as a R, because there is a receiving packet, and there will be a set of packet which will be dropped, so for that you say it as a D. That's what event. Coming to the time, however the name itself specifies it, when exactly that event occurs. It can be any of these 4 events. When that event occurs, that is the time. So again, from which node you are actually receiving from, and from which node you are sending. So it is a source node and to the destination node. And what type of packet? When I say type of the packet, it can be whether it is a TCP packet or is it a UDP packet. Then what is the actual size of the packet, and there will be a few flags which we are going to see, and the flow ID. The flow ID, FID is the flow ID, which already we saw in the previous examples. The flow ID which do varies, or which you can make it, or which you can set in the different set with the different IDs for identifying the different flows of the same communication. Then here the source address and the destination address. Finally we are going to deal with the sequence number. The sequence number will be assigned based on the transmission, and finally the packet ID. And this sequence numbers is unique with respect to the data transmission, and which may be same for the different data transmissions. Again, packet ID will be a unique for every data transmission, which is the packet ID. Like this, there will be a 12 fields in the trace file. Now let's see a few of the examples here. Now if you observe here plus, so if you observe right here plus few cases there is plus, again minus, plus minus, again plus plus plus. So in this example, so the first field, which is the event, what does the event? It can be either plus or minus, R or D. So plus is what? NQ, minus is what? DQ, again R is for receive, D for drop. So here plus, which is the received data from, so at what time it is received, from which node? Node 0 to the node 1, and what type of packet? It is a CBR, which means that UDP service. It is a UDP service. Again, it is what? Size of the packet. So 210 is the size of the packet, and these are the flag bits, and there will be a 7 flag bits. Then followed by the, so if you observe, so this is what till now flag bits. Then we'll be having the flow ID. So this is what the flow ID which varies whatever we said. So flow ID 11, again if you see for this it is a flow ID 2, again there is a flow ID 2, again came across with the flow ID 1, like this. The flow ID will be keep varying. Again, this is, if you observe, what is the source address, what is the destination address, what is the source address, what is the destination address, and finally what is the sequence number. Here also if you observe, the sequence numbers for these packets were 0, again it has come across 1, again 2, 3, again 1, 4, 5, 6, 7, again 2, 8, 9, like this sequence number will be keep varying. But if you observe, this packet address will be unique. Per suppose you try to understand, it is what NQ, you received the 0th packet, you received the 0th packet with the packet ID as 0. Again it is a DQ, which is sending, you are transmitting out of the buffer. So it is what this is what whatever it is received, that is sent out. Again you received one more packet with the ID 1, that you sent out here, again from here, per suppose here it is all plus, so you are keep receiving the further packet with 2, 3, 4, 5, 6, 7, 8. So if you observe, these are continuous. So if at all if you want to send next packet, per suppose here it is a minus, which is DQ in the sense, obviously it is what second, the packet number with the 2 ID, packet ID 2 will be sent out. So this is what the example of the trace file. So till now we have seen about how to have a trace, how to create the TCL file, which is TCL file. Execute, as soon as you execute, how does the trace file will be created? From that, how does the NAM file or the network animator looks like? And if you want to create the graph, so like this, how to create by using the X graph. Then, so we saw about the 5 steps. One is how to initialize the network simulator, how to create the output files, which is trace file and the NAM file. Then how to terminate the network simulator by creating the finish procedure. Then start and end of the simulation. How to create the nodes, how to connect them by using the links, and how to initialize the queue and queue handling mechanism. How to set the maximum size of the queue. What are the agents, TCP and UDP agents? TCP and UDP agents, how to create the TCP and UDP agents, and how to create the application for the TCP, it is FTP, UDP agent, it is CBR application. And out scheduling, coming to the scheduling, it is by using the simple at command, you can at keyword you can schedule the events and initialize the NAM, which is network animator. So with respect to setting the position, color, labeling we saw. Then finally trace file, tracing of 4 tracing objects, NQ, DQ, receive and drop. So, and this is at the 12 fields of the trace file, and we saw those, and here is an example of the trace file. So for if you want, if you more details or any further details, you can refer to this links. So this is what the link with respect to TCL, this is the link with respect to NAM, and if you want to know in detail about the NS, you can make use of this, and this is the tutorial which is available on the NS. So you can go through all these things for the more information. I hope you understood. Thank you.